Hey everybody, it's Joe again. I'm calling in to see if you guys want to try working yourself out with my math. I don't know what I'm talking about right now, but here I'll show you. All right, so right here we had wormhole 2, and this was wormhole 2. And x is a point, x squared is an entrance point to the wormhole. Now, wormhole 2 over frequency equals light speed. Now, light speed minus graviton times pi plus space time equals gradient of plasma. It's like a reverb off of the entrance to the wormhole, but except it's what happens before it will always happen before it. Like what I was showing you in the first half of my this. So this will always happen before it, and you can enter into it with light around it. So you have that. So light speed minus graviton times pi plus space and time equals gradient plasma. Gradient plasma plus pi times acceleration over time to the third is equal to wavelength and pi, but I can't exactly write pi there. I guess I have to write something else. But I could put that equals wavelength without time to the third. There, that equals wavelength, and it is Einsteinian. And then we can make more with what we have. So the first thing I'm going to do is this is to make an easier way out of a wormhole. If you have a gradient plasma, you can see how far away you are from whatever you are close to by going backwards. If this is a spot that looks big, then you maybe want to go to it right away, because the wavelength is going to take you back near it and you come out. And then, or if you want to go somewhere where there's too much energy or enough energy for you guys, you want to go to the end of the wavelength and come out this way and go back in. So knowing that you can do that, it's basically time dilation in its finest form. I mean, time displacement in its finest form, but it can't be the only thing that is time displacement. So what I'll write now is these were just to show you that I already had this, and that's wormhole 2. And then there's that, and time to the third was already figured out on the other sheet of paper right down here. And that, here's wormhole 1. Now my objective is to make with the things that I have, inertia. So I know what I have to do, so I'll try and write that now for you guys and see if it's right. Okay, so we'll start with graviton minus wavelength times acceleration minus mass plus light speed. So let's try and draw this. Graviton minus wavelength times acceleration minus mass it must be times light speed, I think, but it could be times light speed, either way. Okay, so far we got half of it. Times light speed. It's times light speed. Times light speed minus photon. So minus photon sorry. I don't think that's right. I think you need to subtract the graviton from it. So, let's not use a photon, and instead we'll use basic x squared, comma, or if you can't do that, congruent to x. X squared congruent to x. And we were down here, and it's going x squared congruent to x. That would be right, but it's got to be photon then. That looks better. Alright, so that's basically inertia. This equals z no matter what. So graviton minus wavelength times acceleration minus mass times light speed minus x squared congruent to photon. Okay, I think that's all I can do for now. And even this might be wrong, but if it's off, it's only off by a little bit. It's a rough sketch, so there you guys go. I got a Z now, and I put it in my wormhole. And in my wormhole 2, instead of mass, x squared x, we'll take that out, and I'll put Z. Okay, and when we did it last time, it was basically this, and we're doing Z now, so it goes anywhere in the universe where it has to land. If there is a pattern to it, you can find it out in about a minute right here. Dink. You come out of the wormhole. So there you guys go. Happy? Wormhole 2, second try. The only problem is that I think it's with yeah, it's with the multiplication. It's with the multiplication. There you go. Alright, thank you. Have a nice day.